Hi everyone, welcome back to, I guess, Sociology of Math 101. And today, we are going to talk about elitism and racism. And I'll dive right in. Like yesterday, feel free to ask questions as I go. And I'll deal first with the idea of elitism, and then we can have also questions about that part. And then I'll dive into the racism issue. Again, I'm basing a lot of what I'm saying on the study that I mentioned and explained yesterday. So the study that was carried out here in the SIAM with the teenage girls that went to the math camp. But today I also draw a little bit more on studies that were done by other sociologists, and especially to talk to you about elitism and class issues in math. I will present a lot of work by some colleagues, so you will have the references each time of the work I'm mentioning, and a few books to read if you are interested in the subject. So, as I explained yesterday, we know now that gender inequalities in math are really widely recognized, and yet I think that other forms of exclusion remain less explored, and we know quite a bit less about the other inequalities. Though, as we've seen, women are not the only ones that are kind of missing from studies and then professions in math, and the working class people are also particularly absent. I think this is a very interesting fact, and actually, for me, it was one of the most interesting parts of my research since my PhD, because I started studying children, but the issue was pretty much the same. And I must say that it's a widely accepted idea that math and science would be more opened socially. That, for instance, humanities or literature, that it's subjects that are more welcoming if you don't come from an upper class family, if you don't have an educated family background. People, and even sociologists, we assumed that it would be easier to get into those subjects compared to, for instance, history or languages. So there was this broad idea that math and science would be more socially opened. And it's actually something I discussed when I was first presenting my results. Many of my colleagues were quite surprised. And as you will see, actually, this is a false idea. And we have data to support that actually, math and science are more socially discriminating than other subjects. So we are gonna dive into this data and start with school. So again, I will start in school and then move on to the professional world of mathematics. So things begin in school, and here we have results and we have data from around the world, and all over the world there is a strong link between a student's social background and their performance in math. And actually, in all the countries tested in the PISA studies, the one I mentioned yesterday, social class is actually the strongest factor, the factor that has the strongest impact on students' performance, way more than gender. So we talk a lot about girls and boys and their performance in math. Actually, the strongest effect is never gender, it's always class. It's also more impactful than other factors, and this includes the class composition, meaning how many students do you have in the classroom, and do you put together good students or bad students? So do you do groupe de niveau, like it's been discussed widely in France? Or what kind of teachers do you have? Their sex and education, or even wider education policies in the country. So all those factors, class compositions, teachers' profiles, policies, gender, they have less impact than just the social background of the students. So this remains what has the most importance in our math performance. And again, from the international PISA study, on average, in all the countries that are tested, if you look at the performance of students age 15, again, from the working classes versus students from the upper classes, then the gap in their performance is on average equivalent to 2 years of schooling. So yeah, it means that when you are from the working class, you are kind of 2 years late when it comes to the expected performance. This is the international case, but we have a specificity here in France. We are amongst the worst countries in the world when it comes to class inequalities. And this is actually something that we don't talk about. I don't think I've seen any headlines saying that. We have many headlines about girls and math and oh, that's bad. We have, I think, no headline about the fact that we are one of the worst countries in the world when it comes to class inequality. So this, again, is coming from the PISA studies. And since they gather data on a lot of students, they can actually isolate, well, they do statistical analysis to isolate the different factors and then have an estimation of the weight of all the factors. And so in this table, you have an estimation by the PISA study of the share of students' performance that is actually explained by their social and economic levels, as opposed to their gender, the class composition, the teacher's profile, or the national policy. So how much of a student's performance is actually explained by their social class? As you can see, the average, the mean for all the countries tested in the OECD is that about 15% of a student's performance is explained by his or her social background. The minimum, so the most socially equal system would be the one of Macau, and the worst, the most unequal socially educational system will be the one in Slovakia, with about 25% of the performance of students explained by their class. And as you can see, in France, we are at 22.5%. So almost a quarter of a student's performance is actually determined by his or her social class. So yeah, we are, and this is, PISA has different indicators. I think this one was allowed us to see the gap between the countries, but depending on the indicators, for some indicators, France is actually the worst ranked country in the world when it comes to the impact of social class on math performance. So yeah, we are doing pretty bad when it comes to this particular issue. And to make this maybe a little bit more concrete about what it means for students in the social systems, it means that very early you have a very socially segregated math education. And so as soon, in the French system, as soon as the students can pick and choose fields to study, well, then you have very different paths for working class students and students from the upper class. So this is going to be maybe a little bit harder to understand for people who do not know the French system. This is comparing students from a privileged background. The Ministry of Education called them favorisés, les élèves favorisés, and students here on the right from an underprivileged background, so défavorisés. It's not exactly the same as upper class and working class, but it's close enough, so we will consider that. And then you have, in blue, students who do not get a high school diploma. So you know, in France, the high school diploma is called the bac. So students who do not get their high school diploma. Then in red, you have the ones who finish high school and they get a high school diploma. In gray, you have those who get a general high school diploma as opposed to technical or professional. So obviously, general diplomas are more valued and they open more doors for you. And then in yellow, you have the ones who get a scientific high school diploma. That was, we don't have recent data, so that was the data for the students who started high school in 2007, so it's been a while since we got the data, so that's why we have the scientific back and not the new system. But as you can see, first, there is a huge difference in just finishing high school and getting your diploma. So in France, we've been saying that everybody gets the bac. Well, no, not everybody. As you can see, when you come from a very underprivileged background, then it's almost half of students actually do not get that diploma. But then I think the most important and interesting figure is the one about who gets a scientific diploma, because as you can see, almost half of the children from a privileged background actually did get a scientific bac. It's only 10% of the children of the working class. So that's an interesting comparison, because we see that it's the whole system is segregated, but specifically in the science sector. So this data is really compelling, but it's quite old. Yes. Yes, 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 yes. When we say have a bac, it's general and or professional or technological. Yeah, so yeah, it's any bac. And actually, to do a little bit of sociology of education here, the fact that a lot that the part of students that got their bac has been rising is a lot due to the professional and technical bacs. So the rise in education is mostly supported by the non-general bac in France, actually. So this is old data, but it's the most interesting we have. And as I was saying yesterday, we don't have all the data we wish for when it comes to students. And so we cannot do all the comparison that we'd like. But the most recent data we have, and that's the one that was published in 2022 by Margot Deage, is what we know from after the high school reform I mentioned yesterday. We know now that about 30% of very privileged students, but 10% of middle and working class students actually choose to study mathematics in terminal, their final year of high school. So we have this new data. It's a little bit different from the data for almost 20 years ago. As you can see, this hasn't really moved. We still have this the same. Well, about 10%. And what's interesting is that this difference between the choices of the students actually makes the option advanced mathematics the most socially divided option of all the French high school. So again, that's one of the specificity I'm often asked about, but what is so specific about math compared with physics or compared with computer science? Well, usually the specificity comes from math being the worst subject, and here again, it's the most socially divided option when it comes to choices between privileged and middle and working class students. So this is the context in school, and as you can see, so the segregation starts very early. Moving on to, the professionals. Obviously, this has consequences for the professional world, and this has been studied. Again, we are working on with old data, because there was, to my knowledge, only one very comprehensive study about the professional world of mathematicians that provides data on social class, and it's a study conducted by sociologist Bernard Zarka, and his conclusion, I quote him, is that math is the most elitist profession of all. What he did, he was doing qualitative and quantitative work. If you are interested, this is the reference. This is a paper. He also has a very interesting book about math, Bernard Zarka. It's a bit old, but it's the most comprehensive study that we have. And so he had a questionnaire for hundreds of academics coming from math, computer sciences, and physics. And what he did was quite interesting. He had it brings us insight in the family backgrounds of researchers in those three fields. And so, as you can see, is who is coming from the upper classes, meaning again, your parents are from intellectual professions, or they were executives, or they were managers. We don't really have data for all academics, but we know from Christine Musselin's works that more than 50% of them come from, it's an estimation, more than 50% of them come from the upper classes. we have more precise data from Zarka work, and his finding is that, well, again, lecturers and professors in math have a more prestigious social background than those, for instance, in computer sciences or physics, with 70% of them coming from the upper classes. And we were discussing this morning with a few colleagues. If you ever were under the impression that you had a lot of people whose parents were teachers in your surroundings, it's not only an impression, because almost half of you, especially if you do math, half of you have parents who are teachers or scientists. So yeah, it's pretty common. Yes?
What's the percent of upper classes in France?
Again, about a third.
A third?
Yeah.
So okay.
Oops, sorry. So yeah, it's more than in the general population. Even a little bit less, I think maybe 26%, if I remember correctly, something like that. So we have this. We usually use a classification of social classes, and it's based on a nomenclature of professions. And so there is, if you look in the databases of INSEE, the National Institute for Statistics and Data, you have each profession is linked as a code, and it is linked to a category. And so you have, if I remember correctly, 7 categories. So you have managers and executives, cadres. You have intellectual professions, professions intellectuelles supérieures. You have intermediary professions. And then you have, I'm not going to remember the word for agriculteur. What is it? Farmers, thank you. You have ouvriers, workers. You have employees. And so each job is coded and referenced to one of those categories.
So it's a qualitative assessment, not, for instance, how much people earn.
No, it is actually, because this nomenclature is revised every few years and is based, I'm giving you the short version, but it's actually based on a lot of quantitative studies that take into account how much people earn, but also many behaviors, cultural, linked to values. So they actually do, every few years, they check to see if the description of the social class actually corresponds to a way of living, as well as how much people earn. So it's actually the way we describe social classes is fascinating and quite complex. So I'm using the same typology that the National Institute uses. So upper classes here will really be people that are managers, executives, so cadres, that have in their job, they have the label cadre, and also all the professions labeled professions intellectuelles supérieures. So you have a list of this. And so, for instance, yeah, it's the most common examples are academics, are normally in this category, but also teachers from the middle school and high school, not teachers in primary school. So here, for instance, it's an interesting case because teachers from in primary school earn a little bit less, but not that much less than teachers in secondary schools, for instance. But they are not put in the same category because their cultural and economical behavior is not the same. So this is an example, for instance, of a choice that was made based not only on the salary, but also on the cultural and social and economic behaviors of the different classes. Yes?
So you already said that the study of Bernard Zarka, 2006, so it's 20 years old now.
Mm-hmm.
That's fine, but I mean, do we have a clearer picture if we enlarge the window of time, let's say 20th century,
yeah.
maybe late 19th century, if we don't have like a later study by 2026 or 2025, mm-hmm. so that we get so like is it elitist for the early of 20th century, and it has always been the case? Mm-hmm. Is it getting better, worse over time? Do we have any understanding of such?
I'm not sure this has been done, but if it has, it's in a book that I will mention in a second. Because if it's been done by historians. And if it's been done, frankly, it's been done by one historian called Pierre Verschuren. Maybe he has done that. I'm not sure. But I will mention the book, and if it exists, it's in the book. But I'm not sure we have a clear way of documenting social class.
But what is the dynamics now? Because this is in 20 years ago, this study.
Yes.
So I guess this has shifted quite a bit, actually.
We don't know because we have no data. Because this data was actually collected with a questionnaire sent to hundreds of academics. So I would love to reproduce the study. If you have any funding. No, but that's the main issue. We would need a new study to know. So yeah, I know it's frustrating. I don't know.
And I think that there is another thing, maybe more recent, which is that maybe a lot of people have actually less respect nowadays for kind of intellectual things because they don't earn a lot of money. They would say, I did without it, and I'll send my kids to become, I don't know, a butcher, plumber, baker, you know.
Frankly,
I'll earn more and I'll have a better life.
I know that when you see this, I think the first instinct is to say it's better now. I mean, from the data we do have, it's not quite sure. It actually may be worse because yes, the profession has lost a little bit of prestige, but it's also become way more competitive than it was 20 years ago. Because actually 20 years ago was the moment when it was the most open. You had a nice conjecture, and it was also a good moment for recruitment in universities. So, but we have more recent data from the book I was mentioning and studies that were done. And so the data, most recent data, the reference is on the next slide. So I will show you the reference in a moment. But the data I wanted to add, and it's more recent, as you will see, is that we have other indications that even today, the world of research in math is actually one of the most competitive and socially selective that we have. So one of the most competitive fields. And so, again, I will mention this. These new figures come from a study carried out by a team of sociologists and historians. So the main historians I mentioned is Pierre Verschuren, and the main sociologist is Pierre-Emmanuel Menger. So the quote is on the next slide. And they published this last year or 2 years ago, so it's more recent data. And what the data shows is that in the world of math, selection is really powerful and it starts really early. So it's not a causal link. So it's not if you're a boy you'll become a mathematician, or if you if you skip a grade you'll become a mathematician. It's just when you take the professional group, some profiles are way overrepresented. So what? Parents being teachers, obviously, it's almost half of the population. That's the figure from Zarka from 20 years ago. Obviously, being a boy is a favorable condition. But we know from the following study that other favorable conditions are overrepresented in mathematicians, and those are to skip a grade. It's a third of academics in math. Also to have the bac mention très bien, so to graduate with honors. And also no figure for that, but the qualitative studies shows that having been in the concours général or in the Olympiads is pretty common also for academics. And then, I'm sure you know about it, but there are some favorable conditions in the path that people follow in higher education. So for instance, coming from the grandes écoles or top school, that's half of the mathematician. Having the agrégation, so everybody knows what it is? Good. It's so important that obviously everybody knows what it is, even if it's very French. And also having your PhD in Paris, a third of the population. So
here I nonetheless would say that this is fairly biased.
Probably.
The left column, I agree. This is something nobody can do anything about.
Yes.
But I would not call the middle and the right column conditions. Because, I mean, if you look, let's say, at a professional soccer player, They
Yeah.
will be good at sports. If you put this as a condition, being good at sports for becoming a professional soccer player, what are you measuring? I mean, if you're good at math, if you're good at, you discover yourself as a kid being good at math, you will naturally be interested to go and do some math Olympiads, for instance, right? Because it's fun if you're good at math to do this. So I wouldn't call this a condition, right? I mean, it's not. It's something that people who are good at math will naturally search to do.
She didn't say it's a condition, it's just an observation.
Yeah.
It's the word you use is condition, right?
Oh.
It's like if it's something that is independent of.
No. I think this is actually because condition may not need the same. I think it doesn't mean the same thing in your language and mine. I think that's it. Yeah, I think that's a malentendu. When I mean condition, I mean it like a social condition. So it means your status in a way, not as a logical condition. I think that's the reason of the misunderstanding. I don't mean it as a logical condition. I mean it as the condition you are in. So as do I make sense? So yeah, I agree. It's confusing because we don't use the word in the same way, and math has a very precise way of using words. And then, so yeah, I don't mean as a logical condition. That's right, because otherwise, yeah, you are right. I mean it as favorable conditions mean favorable characteristics of people.
It's a correlation.
Yes, exactly. It's a correlation. Yeah, that's it.
That would be a better way to call it in that case.
But if I did that, nobody else would understand.
It has a different general meaning, right?
No, you are right. But this presentation is not only given to mathematicians. And usually, if I put correlation, then nobody understands. But you are right. We are in agreement in this.
And at least correlation doesn't explain something.
Yeah, no, that's right. Absolutely. Yeah, no, it's not a causal link. It's as you said, it's an observation and a correlation. We are not saying if. Yeah, imagine if you're born a boy, your parents are teachers, you skip a grade, bim, you become a mathematician. Well, no, obviously, no. But more correlations you will probably enjoy. Again, so this is the reference that I've been mentioning for a while. So the one by, that's Pierre Michel, I missed his name. Pierre-Michel Menger, Jan Renizio, Pierre Verschuren, they studied careers of mathematicians quite a lot. And they have a historical perspective. And it's the most, it's a recent work, so it's been done in the last 5 years. What they proved is that it's not only becoming a mathematician, it's that those social characteristics are also linked to your position, your relative position then in the field. So, and this, I presented this once already in front of a room of mathematicians, and there was a huge debate about what do we call a mathematician? Who is considered a mathematician? A terrible thing. So, what do I consider a mathematician? I'm using the same definition that my colleagues, Menger, Renizio, Verschuren, and all of them. So we call mathematicians people who are actually teaching and doing research on math in higher ed contexts. So this excludes math teachers from middle school and high schools. So yes, it is arbitrary because some of them have PhD, some of them went to grandes écoles, etc. But they are not in their professional capacity teaching or doing research in higher education. So this is a restrictive definition of mathematicians. And again, it's not us deciding that some mathematicians have values and others do not. It's a reflection of the status and activities. So, I'm considering as mathematician in France, people who work as researchers in the CNRS, so chargé de recherche and directeur, directrice de recherche, people who teach in classe préparatoire, and people who work in universities, so maîtres and maîtresses de conférences, and professors. So, as you can see, there is again, correlation between where you studied, if you got the aggregation, and I put back the gender indicator because it's interesting. And so as you can see, that the difference between, for instance, working for the CNRS, class prépa, universities, some things are pretty normal, like people working in class prépa all having the aggregation, that's a condition. This time, so so that's normal. But what is more interesting is the link between where you did your studies and if you went through a grande école, and then if you work for the CNRS or for universities, for instance. So what is interesting is that I'm pretty sure you are not surprised to see that the positions that are considered the most prestigious, like being a researcher for the CNRS, are the one who recruits the most. Are the one who recruit the most person who went through the also very prestigious grandes écoles, but also the least women. So there is a link between the status of the job, the path you went through during your higher education, and your gender. But since this is all very sensitive data, we can now take a step back from math, because all of this, the link between your sex, your social position, and what you study, and the job you have, etc., is actually not specific to math, as I'm sure you've guessed. So I wanted to take a step back and to present to you a sociological concept that is called the social and sexual division of knowledge. And it's a concept that was formed by a philosopher and sociologist who's called Nicole Mosconi, and she was actually studying primary schools at the beginning, and so she studied children and then teenagers. And I think it's a pretty interesting concept to understand the way that our social backgrounds and our gender, so that's the social part and the sexual part, actually have an impact on the subject that we want to study, and then we do study in universities. So, what we know is that there is a difference, an important difference in the profile of the students and the subject that they study. So this is an interesting analysis of data. It's looking at the part of female students, and here looking at the part of students from the upper classes in the different sciences that are taught in our universities, so in French universities. And this is data from the students in their first year, so en licence 1. So, as you can see, when we look at the profiles that we have for the students, and so this was done by other colleagues that did pretty interesting work. They did work on the ENS. There are Marianne Blanchard, Sophie Orange, and Arnaud Pierrel. If you are interested in the work, it's La production d'une noblesse scientifique. What the analysis of the data shows is that you kind of have 4 big groups of disciplines in the French university. The first group you have is the elite and male-dominated field, so it is represented here in yellow. You have here the preparatory classes, the classe préparatoire MPSI, here. You have the licence of the bachelors of sciences physiques, so physics, but also this is the, I don't remember, the PCSI, the class préparatoire PCSI. And you have, I think, the most masculine and elitist of all is actually the bachelor in mechanical physics. In this group of disciplines, you have less than 30% of women, but you also have more than 50% of children of executives and intellectual professions. Then you have the elite, but female-dominated fields. Here you have the classe préparatoire in biology and chemistry, so the BCPST, but you also have medicine and pharmacy, and you have the bachelors in biology and chemistry. Here you have more than 60% of women and more than 40% of children from the upper classes. If we lower the social recruitment of the disciplines, then we still have a male-dominated group of disciplines and a female one. If you look at the male-dominated one, then you find engineering, science, and technical and industrial training. Less than 40% of women and about 40% of children of the upper classes. And finally, this group of disciplines that is a little bit more popular but also female-dominated, and there you have the life sciences like geology and biology, and the training to become a nurse. So, in other words, when you look at this repetition of students in the different sciences, you can say that the more theoretical and abstract a science is considered to be, the more elitist and male-dominated it becomes. So there is again this correlation between the status and the representation of a discipline and its recruitment of students. And so conversely, the more applied, the more technical a science is, the more male-dominated it is when it applies mainly to matter, objects, machines, techniques, and the more female-dominated it is when it applies to living organisms, so like the life sciences or the nurse training. So computer science is here, and these are the bachelors in universities, math and physics here, and the bachelors in math are here. Yes?
Just on the graphic, why is the red thing on 60 and not on 50%, for example?
Oh,
Why
because...
it's not half-half, why is this separation so?
Oh, because actually 60% and 40% are the limits we consider to say if a field or subject is has reached parity or not. The definition of parity in jobs or anywhere is actually more than 60% or less than 40%. That's the definition of parity.
Why?
It's the statistical definition. Because imagine if we decided that we call, for instance, let's take jobs. Is a job, I don't know the adjective, paritarious? No?
Why not 40%? Why not 40% then?
It's between 40 and 60. It's yeah. We consider that...
You see the line 60, not the line 40.
Yeah, that...
There are two lines missing. Is that what you mean?
Yeah, because I think they are the one who make the most sense to distinguish between the different, the four different groups. Yeah, we could put the line 60 here, and we could put oh no. It's all right. Okay. Oh, the next plot is going to drive you crazy. So. Yes.
Could this 40 or 60% ratio be based on the general population in university, Bachelor 1? And so they could explain that, for instance, 60% of the Bachelor 1 students are female, actually?
No, because it's 52, I think, so no.
I
Okay.
think that's only for illustrate something
Yeah,
that they put this accent. That there is truly feminine fields.
Yeah.
Okay,
I
and
agree.
upper class.
I just wanted to maybe find...
It was a good hypothesis.
60 in this axis and 40 in the other.
So, fair warning, yes. That's the next one. But, fair warning. So this graph was taken from the book by Marianne Blanchard et al., and it was redone by my illustrator, the illustrator of the book, Claire. The next graphic we could not redo, so it's the original one, and fair warning, it does not start at 0. I'm really sorry about it, and it's quite ugly. So, yeah. As you can imagine, I've had issues with this before. But it's the only one I have, and it's the only data we have, and the data is not freely accessible, so I do have to rely on the work. I put his name here if you want to write hate letters. That's him. That's Jan Renizio. Actually, huge and very important work he did, and very interesting. So yeah, to answer your question, if we take a step back again and we de-zoom on the issues, then we have actually the same thing for all fields. So not only for the sciences, but for all fields. So again, here we have the proportion of male students, so it's the other way around. Here again, we have the proportion of students from the upper classes. And then you have the faculties, so the classification of the universities, with obviously the sciences, the humanities, law, economy, and management, miscellaneous, pluridisciplinary bachelors, and then health. And so as you can see, again, here, we have the fields that are the most elitist, and they are the medicine, but also political sciences and philosophy. They have more than 50% of students from the upper classes, and between 40 and 60, now it's 70, I think, % women. Then you have the group of math, physics, computer science, so that would be in black here, again, where you have a bit less, but still between 30 and 50% of upper classes, and the least women. But I think the interesting facts from this graph is that the group of disciplines that actually welcome relatively the most people from the working classes and women are actually the humanities, and more specifically educational sciences here, psychology. These are languages, so French, but also other languages. Sociology is here, and this is languages science. So as you can see, this group of disciplines, the humanities, excepting philosophy, which is up there, remember what we said yesterday, this group of history is here, for if you were wondering. So this group of disciplines is actually, compared with others, the most open socially. I'm as sure you know, it's also the most devalued group of disciplines in the French university. We get the less money, I'm saying we because I'm obviously here, we get the less money, the less funding, and the less respect also. It's actually not only symbolic, it's actually effective. People who graduate from these fields it's harder to get a job, it's harder to have high salaries, and it's harder to get a managing position. Yes? Yeah.
Gender segregated field, but that doesn't really seem to appear here. I mean, between 40 and 60%. Does that get worse as the years of study go by? Or like for example, master's degrees, they're worse?
Yes. Because, so as you see, philosophy here starts with less women than other humanities. And then a lot of them go into teaching. So when you look then at people who are in the universities, it's a very small group of people, and that's where it is very female deprived. So yes. So yeah, there is again this link between the status of a discipline and the social status of its students. Yes?
I think in literature, if you look at students not in the university but in university,
sure.
you will have something completely different.
Absolutely.
From the point of view of the social background.
Absolutely. Yeah, that's true. In this graph, in the previous graph, it was a mix of universities and classe préparatoire. In this one, it's only universities. So yeah, if you look at the classe préparatoire, but classe préparatoire in humanities have a very small population of students, less than the one in sciences. So it's a very small population. Also, recruitment for academics in the humanities are less linked to their career in grandes écoles. So there is less of a link that there is in math and physics between going to a classe préparatoire and then grandes écoles and being recruited later on as an academic. But yeah, the social recruitment is very different, and especially for the social background. Classes préparatoires are not very welcoming for people from the lower classes, absolutely. I don't know the figures by head. All right. So this was to illustrate the concept of the social sexual division of knowledge, meaning that we don't foster interest for a field or a subject just like that. The subject that we choose to study is actually pretty well constrained by our social status and our gender. And this obviously is linked to the representations that we have, both of the subjects, like are they more abstract or more theoretical, or are they more concrete and applied, and of gender and class. Who is interested in the different fields. The next issue I wanted to talk to you about, it's actually going a little bit further and trying to question the link between representations that we have of math, and the repetition of the different profiles in the different subfields of math. So what I wanted to talk about is what I call as a sociological concept, the disinterested taste for math. And this, as I will show, is a strong social marker. So here we dive a little bit deeper into sociology, and especially into sociology, if some of you know, that was founded by Pierre Bourdieu, who did a lot of, between the 60s and the 90s, he studied a lot about people's tastes. Why do we like something and dislike something? And why do we choose to pursue some interest and not others? And one of his main results is that tastes is really deeply linked with our social positions. He mainly studies the impact of class. And Bourdieu was primarily interested in our taste in art and literature. So for instance, he did a lot of studies on people visiting museums, he and other colleagues as well. Why do people like this kind of art and not this one? He did also a study on photography. Why do some people like this photography and not this one? What is considered beautiful and what is considered hot and interesting, depending on your social background. And one thing that he proved is that disinterested taste, meaning a taste that is completely separated from application, utility, or even this thing is not going to be useful to you, this particular taste is really linked with a higher up social position, meaning that the higher you go in society, the more people have the material condition that allows them to just be, I don't need something useful, I just need something beautiful, to make it short. So Bourdieu explained that there is this difference in taste and that you have this disinterested, he also called it the aesthetical taste, versus a more pragmatic and a more applied taste. And actually, when I started my studies, one of my hypotheses was that all the work he and others did about art and literature could actually be transferred and explain taste for science and taste for math. So I tried to do this kind of translation of those concepts and see if they applied to math. And well, indeed they do. Indeed they do, and what we notice, and the reason actually social reproduction is so strong in math, is because the way the career works kind of selects people whose education and social background best predisposes them to professional research. And so in math, you also have this difference between, on one side, a disinterested approach and relation to math, and on the other one, a more utilitarian relationship. So what is a disinterested or aesthetic relationship to math? Well, it means that you are more attached to the form rather than the function. So how are things done rather than how are they going to be used? It also means that, and this again it comes from Bourdieu's work, that when you do math, when you do your research, there is a distance between who you are yourself, your interests, your personality, what you think you are, and the work you are doing. There is no link. You have no, you reduce the link that there is between yourself and the work you are doing. It's also a focus on more abstract thinking, and I think that's the most important thing, detachment from more concrete experience, but also detail. On the other hand, what is described as an utilitarian or practical relationship to math is when you are more attached to the content over the form, but also when there is actually a proximity between the research you do and your personal experience, but also the context, and a more focus on the concrete, but also more participation, more identification. I am aware that this is maybe not evident to understand, so I will try to give you a few examples of what it means to have this disinterested relationship to math. Because when I was doing, and it's coming back, we left it a little bit, but when I was doing the study on the Cigale, on the girls in the Cigale camp, we noticed that most of the researchers were actually studying in pure mathematics. And when they talked about math and when they presented math to the girls, they used a language and they presented math in a way that, as you will see, really represents this aesthetic or disinteresting relationship to math. So they tended to present math as being a game, as being very fun, as being really beautiful, but also as being extremely uncertain in a way. So I will translate one of a few of the verbatims. For instance, here we have a researcher, and she said, "Well, math research can be useful, but for me that's not the most important, because the most important is just being curious. Do questions need to be useful for us to answer? I don't think so." So it's the way of saying it doesn't matter if it's useful or not. This one was saying, "When I do math, I am allowed to do anything I want. Don't ask me if it happens in real life. I really don't care. I don't care about if it's useful or if it could be applied. I love it when you have pretty pictures." This one was saying, when you do math, you can create your own problems, and that's cool. It's a bit stressful, but it's also a lot of freedom. This one was saying that every time you need something, you can just invent new things. Or this one, that we play with objects and that you can have fun trying to find when they are, and it's really fun. And finally, he said that his job was to be all the time facing things that had no solutions and to feel at ease like that, even if it can be troubling. So these are just a few verbatims that I'm sure you've heard. I mean, we've heard some even yesterday. It's all fun and games. We don't care about the apply part of thing. We're just here to just take advantage of the freedom, the liberty, and the fun. This is all good, obviously. This is not a problem in itself. But what the observation during the camp shows is that what the researchers were saying did not ring the same for the girls depending on their social backgrounds. So some of the girls really recognized themselves when they heard these kind of things. For others, it was a very, very weird way to look at life because they did not have this disinterested approach to things. And as I will show, this was directly linked to their social background. So the final things I wanted to bring for this talk about elitism in math is actually that going back to our teenage girls, we were able to show that there are different ways of liking and relating to math depending on your social background and here your gender. So this is exclusively about girls. I don't have data about how the way teenage boys relate to math. So this is relationships to math determined both by gender and class. So in our group, we were able to identify kind of 4 different ways to relate to math, and that, as you will see, some of them are very compatible with what the researchers were saying. Some of them go very far away from what they were saying. And so the first way to relate to math is actually considering that math is really useful if you want to help others. So a very utilitarian approach to the discipline. this was something that we found for the majority of the girls, so more than half of the group. They told us that they like math because it was useful in high school because they wanted to become doctors. And so they had to study math because it was a way to get to their dream of becoming doctors, and they wanted to be useful. The key idea was, I want to be useful, I want to do something useful, and I want to help others. As a result, they did not recognize themselves in the profile that the researchers were mentioning. For instance, Ida was saying, well, I really don't like it when I don't find the answer. I have no time to wait. And when you do research, you are never sure you are going to find something. She was saying, I'm not really patient. If I don't find it, it's going to bore me very quick, so I'm not the one for this. Or I really don't see myself being a researcher, wake up in the morning and look something that's going to be useless. So these girls, what is interesting is that they are presenting themselves as not being patient, as not having the right personality for it. But actually, they were all coming from the working classes. When you think about it, it makes no sense to lose time. Because if you lose time, you lose money, and then you lose basically your ability to eat and to have a roof over your head. So from a material perspective, it makes absolutely no sense to love losing your time, or you don't really have the luxury to be able to pursue something that is not going to work. You have to have something that is actually practical. The second type of relations that we have to math was math for technology. And these, it was girls who targeted fields like technology, IT, engineering, but also economics or business. Again, they had a very practical and utilitarian approach to math. They wanted to do something and do something concrete, but they came from a little bit of a higher economical class. So with parents engineers, parents in business. So the family had money and they wanted to keep having money. So for them, the issue was, how can I use math to get a job that is going to earn me good money, but also being useful? How can I do both of them? So a few quotes from them. For instance, Jad saying, I prefer math when they are well applied rather than research math, because I love problems when you know how it's going to happen and when it's not uncertain. Ella was saying that research is complicated because you don't have the answers. I like when 2 + 2 is 4 and I know it's 4. When you do research, you can spend 5 years on a project and finally it's worthless. See the difference between them and the girls before. She's saying it's worthless, not I'm not going to find the answer. It's an economical way of saying things. And she's saying, I like math when it's concrete because it's useful for physics. I don't like to do things just to do nothing. So again, it's as you can see before with the girl before, it's a little, the approach is similar and yet a little bit different. Third relationship is using math for academic success. And here the key issue is to keep being good at math because it opens doors for your future academic career. Those girls, they like math because they feel it's the most certain way to get good grades. They have a certain certainty, it's easier to get good grades, and they also have this practical approach to science. Here we find parents with close ties to the school system because they know that it's the better way to get ahead. Also parents, so teachers and civil servants. So for instance, you have Leah, whose mother insists that she keeps a passion for science alongside her passion for art, because she knows that math is the better choice because you can get everywhere. And she's like, I'm not bothered by math and research, but what I like, what is good for me in the math we do in class is that we have a solution and a result. Or this girl, Magali, who says, I could have done anything, but math is the one that closes the least doors. And I like it because it's, the solutions are square. So, as you can see, in all of those ways of liking math, we did not find the way that the researchers love it, for the uncertainty of it, for the games, for the play, for the beauty. None of those girls mentioned this. The only one who mentioned it are actually the one from the families where you already have academics and math researchers, and they are the ones who like math for knowledge itself. So this disinterested way of loving mathematics. This really was the minority, And here the key issue was just enjoying yourself and being free. And here you have the taste for complexity, for uncertainty, for unfinished business. Like Ségolène, who says, I don't like probabilities, even though it's the easiest. Because for me, it's actually the hardest because it's the most concrete. I want something more, I prefer it when it's more abstract. Or Lou, who said, I would love to be a researcher because that's where you can have fun and that's where you can be free. Because going into a firm, it's really the, I mean, I can't even translate it because of the way she speaks. It's antonymous with my values. I prefer to do nothing than to go and be an employee in a firm. So again, notice the difference between her and the girl from the beginning, because who can be like, I prefer not to have a job than to have to go into a firm if I cannot be a researcher. All those relationships to math make sense if you relate them to both the social positions of the girl and the fact that they are girls. Especially the first one, when you see that helping others and being useful is very strong, because I'm doing the short version here, but most of their lives, girls have been taught that they do need to be very useful to the one around them. I'm actually going to stop here for the part about elitism, hopefully having shown that, well, first we have this data that shows that math is particularly elitist in its recruitment, and then hopefully with this result with the girl, showing the link how the way you were raised can create in you a different relationship to math, and that only one of those type of relationship is very valued in the path that leads to careers in mathematics, and hence it explains the way that this selection works and keeps only the people that have developed this state for math as a game and as fun and as freedom. Not everyone can actually develop these states, and you need very specific conditions, as in living conditions, to develop this particular taste. Any final questions on the elitism part? Okay. So we can have fun. I'm going to skip the conclusion. We can have the last of the fun with the question of racism. To be honest with you, when I first started to do this sociological study on science and math, back when I started my PhD, racism was not actually my main focus. I started really focusing on gender and on class. But then I did my field study. The first field study I did was in Lyon and in a disadvantaged neighborhood, in a réseau d'éducation prioritaire. So the race issue kind of became evident because I was working with students and almost none of them were actually white. So pretty soon the race issue became prominent in my work. And yet, we have a terrible, terrible difficulty working on race issues in France. As I've said, we have no data, but even in French sociology, it's very controversial, and we have a really hard time just talking about racism and proving that it exists. To preface what I'm going to say, I must say that both in the humanities and the social science, we know that there is no such thing as a reality of human races. So biologically, there is no actual difference in human beings. There is no biological race. But yet, there is a social race, meaning that there are discriminations and there is racism. A way to say that is that, well, yeah, there is no biological race, but there is social racism. And so that's the short defense for the interest of talking about it and documenting it and mentioning this thing. When we went into the observation for the Seagal camp, again, racism was not our main focus, but since I had studied it beforehand, I still had kind of an opened eye for these issues. And what I wanted to start with is by telling you one of the interactions that we observed during the camp. And it's an interaction between two girls. And so, as I said, the girls spent the week here in Serum and they worked on research problems. At the end of the week, they had to do a poster to show the results of their research. And so this interaction happened when two girls who had been working together all week were trying to create the final poster. So one of them is Magali. You've seen it before. Both her parents are math teachers. And the other one is Ida, and Ida is a black girl, and her parents are workers. So she comes from a working class background. So they worked on the problem together for 4 days, and on the last day, well, Magali is giving orders and she is trying to supervise Ida while she is criticizing her attitude. So here Magali is saying, you do that, all right? I'm going to take care of the definition. You draw the line. Well, the line is too big. So Ida is like, is that okay? And Magali is like, all right, you do that, and now you just draw the lines. So Magali is dividing the work. She's doing the math work. Ida is supposed to do the drawings and the lines on the poster. And she's being quite forceful. So at some point, Ida, she's performing a manual task. She's writing under dictation. She's cutting out the sheets of paper. And at some point, Ida starts dramatically playing the role of the employee. And so she starts calling Magali miss or lady, and she starts using formal language with her. So for instance, she's saying, miss, do you confirm this is okay? And Magali doesn't seem to notice the shift in language, so she's like, well, yes, but make sure it's really straight. And so Ida protests, but it is straight. And then she says, you should listen to your employees, if you know what I mean. And so she's like, the employees? Yeah, I mean me. And she's like, just go pick the markers. And this goes on. This goes on with the next scene where Ida really gets into the roles and she says to Magali, you just tell me what I do, what I have to do so we can move forward. I can only be an employee. I'm not the one who can be a manager. You just show me what I have to write and in what color I have to write it and I will do it. And the other guy goes, all right, well then I'm going to dictate the next part and you write it in green. And then Ida says, I'm listening to you, ma'am. I could not be the manager, because if I was the manager, I would fire everyone. Magali is still ignoring and pointing, just don't make mistake when you write. Then Magali tries to include Ida in the work, saying, do you want to write the title? And so Ida is like, no, you have such a lovely handwriting. Do you want to write the formula? No, you just tell me what I do and I do it quickly. I don't, and she's like, I really don't trust myself. I really don't have confidence in myself. Well, then you can cut out the paper. And so Ida is like, yeah, I am part artist. That is why I'm the one cutting the paper. Well, that's not the only reason, but... Then the adult, Pascal Hubert, for those who know him, called the break, coffee time. Ida says, I want a coffee. But Magali says, I don't need a break. Even that we are doing the poster, that's not even math. So that's one of the higher motivated girl. And she's like, yeah, obviously you want to have a break. And then Ida leaves and she does this very theatrical thing when she starts talking about herself in the third person. And she said, they saw this work and they said, Magali did it all. But no, Ida, very annoyed, said, it's also Ida that did all the work. And then Magali says, come on, Ida, I need you. You come here, you sit, and you try to concentrate. So, what's the meaning of this scene? Just to make myself clear, Ida comes as very sarcastic and very ironic in the things she says. She's not a victim of the situation in a way. But Magali doesn't pick it off. And in this sense, we can use here, and I'm using a concept brought up by a political scientist called James Scott, and he has shown that when people are in a position of domination, like it's obviously the case for Ida here, they can use this way of playing a role and creating kind of a theater scene, because it's the only way they can kind of politely react to the domination. So this is exactly what is going on here. Ida tries to challenge the discourse by just showing how absurd the dominating position is. Sadly, this interaction is something that we noticed several times during the camp, where we had these dynamics where in the interactions, you had some of the girls, the white girls, and the girls coming from the most upper classes, they tended to talk more. They tended to give orders. They were also focused on the math content, and they were the ones who talked about the work in front of the public, while the girls, both racialized and from the lower classes were the ones who listened, who were doing who executed the work, but who also did the work on form and the stay in the background. So, coming from these examples of the girls, what I wanted to talk about now was the way that we still have racial discrimination in math. And for that, I went a little bit over my time, so I'm going to give a few references, but we have very few data and very few studies on actual racism in math, so it's actually really hard to document it. But what we know is that in the history of mathematics, we are kind of presented with a unique model of what is a mathematician, and that this model is actually, well, rarely a woman, and even more rarely someone who's not white. And this is because of two reasons. We have two main ways of presenting what is a mathematician, in, for instance, in the history of the disciplines or in fictional work that may present what mathematicians are. One way is to kind of hide the mathematician behind his work. Like it's really like his identity does not matter. So if you make the scientist disappear, well, it has no identity. So as we know, the neutral identity is never a woman. It's also never a person of color. And another way to present the mathematician is to present then him as a hero who changes the world. And I'm sure you know better than me the gallery of heroes that you have in math. Some dying in duels and things like that, and some having mystics experience. And they are always, almost always men, and rarely people of color with one or two exceptions, and rarely also people from the working class. So studies of the history and structure of the disciplines have shown that actually in the past, mathematics, like most of the other sciences, have been used to legitimize a lot of racist oppression. So in the past, it has been used, math and its application, to legitimize slavery, but also segregation, but also colonization or eugenics. And that today, it is still the basis for a lot of sexist, racist, or classist injustice. One example that I'm sure you know even better than me is the models on those on which many algorithms are based. And if you don't know about it, I really recommend, I think one of the most eye-opening books on these questions are the one by Sarah Hottinger. She has a book called Inventing the Mathematician, Gender, Race, and Our Cultural Understanding of Mathematics. This one is a really well-documented book. But I think one of the most interesting is the work by Cathy O'Neill. In French, it's called Algorithme la bombe à retardement, but the English title is better. The book in English is called Weapons of Math Destruction. Good title. Cathy O'Neill used to be a computer scientist, and she made a very good book about the way that computer science and its application have been used against and again at the disservice of women, people of color, but also the working class. She has very fascinating example, for instance, from the way that those algorithms are used in insurance policies or in public surveillance. I'm going to use the rest of the time.
So
yes.
This is a lot of different things together.
Yes.
It's a bit but for instance, this very first thing, can you give some examples of this assertion that mathematical knowledge legitimizes racial hierarchies?
Oh. Well, I think the most recent example from Cathy O'Neill's book, for instance, I think the way algorithms are used to base face recognition technologies is maybe one of the most evident examples.
Yeah, but I'm not sure that I would qualify this as mathematical knowledge. Of course, we know now that all the social networks and AI and so on. Okay, there is a mathematical component in it, and it's a dangerous technology for many reasons, but somehow, well, is it really mathematics? That is already, I think, a question. One could say it's computer science.
I think to give a to give a quick answer to your question.
And also mathematical knowledge. It's just also the vocabulary, which somehow seems not entirely appropriate for this kind of.
Maybe if you have an answer.
Yeah. No.
If you have time at the end.
Yeah. No, I think maybe you've noticed that everything is mathematics when it comes to bringing good to people. I'm sure you've heard, everything is math when it's all good. Every time we talk about potential issues, then nothing is math. So yeah, what is it? What is mathematical knowledge? We will not agree on the definition today, but it's knowledge, it's application, it's uses, it is linked. So why do we want to, whose interest is it to disconnect the both, to disconnect math from all this issue? Is it a way of saying that's not my problem, some other people should deal with it? Because it usually is, and well, that's alimenting the problem, right? So yeah, I will not go more into this right now. What I wanted, other things I wanted to tell you, and maybe to finish up the talk. Again, it's really hard to talk about racism in math because we have no data, almost no data. We have almost no, for instance, statistical evidence of the absence of people of color in math. I gave you pretty much the only figures we had yesterday, and that there are maybe 5% of black students in bachelors in the US and less than 1% of them as PhD students. I think this book by Sarah Oettinger is the only one I found that interrogated these issues. So if you want to know more about this, this is the reference. And again, the one by Kathy O'Neill is not focused on race, but it's another good reference. But we don't have a lot of data. So the best I could do, and that's what I'm trying to do today, the best I could do is put forward questions. We don't have all the answers. Is it a rigorous scientific demonstration? No, because we have no data to do that. And actually, the fact that we cannot gather the data is proof itself of the issues. And so the last thing I wanted to say is maybe I'm skipping a bit of the examples I wanted to give to you. But the final examples I wanted to say is about the reality of these things from the girls we had in the math camp. So I provided examples of the interactions that we had. When they went to the math camp, they did experience some extent of racism, but also all the girls that were not white during the camp had examples and had stories of being discriminated against. It was the case for black girls, from Arab girls, but also from Asian teenage girls. So this is part of their testimony when they explained that they did experience harassment for various reasons, including their skin colors. Or even Emma, as an Asian girl, this could be perceived as a reverse discrimination, but yet, as she explained, it's still racist and problematic because it makes the association between race and a personality of cognitive traits that do not exist. Or the last testimony from Farah, who explains that she had a very bad experience in middle school where she was the only Muslim girl and that some comments were borderline. The last part I wanted to mention, and I think here you can understand it better, is that all those girls had a very weird experience here at CIRM. Because they were made, they experienced that they were very different from the normal public of CIRM, and that especially during lunchtime. You've all had lunch at CIRM. So I'm sure you've noticed how it goes. It's quick and it's sometimes a little bit forceful. If you have, yeah. And that's fine. That's fine if you blend in with the group. But I'm sure you've noticed if you do not eat the normal lunch, well, there is a normal version of lunches, and then there are different versions of lunches. And you have all noticed that we have these badges with little colors, and since the camp, they have been writing things like you eat fish, you don't eat fish. When I was there with the girls, you only had colors, so some of the girls had colors and others did not. Some of the colors referred actually to their religion, because some of them did not eat pork, and interactions we saw were repeatedly every day. So imagine you are a teenage girl. Every day you go for lunch in the Siam, and every day someone is like, do you eat pork? No. Why? I don't eat pork. But why? I just don't eat pork. You don't like meat? No, I don't eat pork. Every day. Every day. Repeatedly. Imagine being a girl trying to do Ramadan here at the Siam at lunchtime. Yeah. So, those girls, when they came here, what they experienced is they realized that they were the only ones, because there is the teenage group, but there is also usually a conference like yours. So you look at the people in the conference, you're like, well, no women, that's one thing, but what about black girls and what about brown girls? Even less. And then you go around in the place, and you experience all these interactions with the other girls that just take the lead and make you their executives, and then the interaction with the adults. And the main message is always the same. The main message, and I'm sure some of you have felt it, is you are weird. You are not the person we were expected, and you are not the normal person here. And I think that's the message for both the elitist parts of the discriminations and the racist part of the discrimination. Elitism or racism, just like sexism, is always a way of saying to certain people, you're not supposed to be here, you are not the normal picture of a mathematician that we usually have. The conclusion I wanted to bring to this talk is, as Vincent mentioned for the today, as Vincent mentioned yesterday, we are in a very problematic political context, as you all know, I'm sure. 2 years, well, a year ago, maybe, I think it was 1 year ago, when Donald Trump came to power again in the United States, he decided to create a list of words that would become red flags for any research project. And so these are some of the words that were on the list that would become red flags for research projects. So if your research project have those words, then, well, your research is under threat, and you may lose your fundings. And we've seen then that many research lost their fundings. So, as you can see, we have women. They put women both in the singular and in the plural, just in case. So you have women and women, just to make very sure. We have things like historical, like systemic, like equity, and so on. So, at that point, as you can see, my career in the United States is very compromised. But to end up with a touch of hope, we are living in a very dire situation. The research on inclusion, diversity, racism, sexism is very under threat, like actively. And so when this came out, it was pretty depressing, and I'm trying not to get too depressed so I can go on with my work. So I propose to conclude with this, prepare to be amazed by the visual effects. What I want to say is that if one of the first decisions by Donald Trump was to try and forbid us from using these words, then we can take comfort in the fact that it means those words have meaning. And I wanted to finish up like that because I know that some of what I've said today, especially about the racist issue, is insufficient. And I know that it's a lot of words, and especially in a room full of mathematicians, not enough data, not enough proof, and not enough arguments. I'm aware of this. We don't have enough to actually, I think, provide a compelling scientific discourse. And yet, I do think we need to provide any other kind of discourse, because behind all those words, we have people who are suffering, people who are being insulted, harassed, assaulted. even in our professional communities and even in our scientific communities. So my hope is that we can keep collectively using those words because as the war against them has shown, they do have powers. Yes, they are only words, and yet they do things. So I'm going to keep using them, and I hope that all the course encourages you to use them too and to discuss these issues amongst yourself. There are no easy fix, but we can, I think, all collectively do better. And thank you.
Thank you very much. Are there more questions? We have a few minutes. Yes. Professor Safi.
Professor Neger. Thank you very much for your talk. I have a question about data. If I remember well, there is a group named the AK Discrete who started to collect in a quantitative way.
Okay, interesting.
Some data about discrimination at universities. Are you aware about this, and how does it connect to your work?
No, I'm not aware of them. Is that for, is it French or is it international?
It is French.
It is French, okay. No, I'm not aware of their work. We have some data about discrimination in universities. There was a study done by a European institution about discrimination against students as a whole. One of the results is that gender is the first cause for discrimination, and racism is actually pretty low, but I think it's actually explained by the very few people that are actually here to experience racism at that point. So yeah, we have data on discrimination. It exists, but to my knowledge, none that is more precise, especially by field. So I don't think we have any idea of knowing if discrimination is worse in some sciences than others, for instance. But I look into so it's AK discrimination? Okay. 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 Thank you.
Thank you very much for the second part of the talk, of the course. So my question is for Sigel, for instance. Have you discussed, or the girls discussed, actions they would like to see in order to, reduce all sorts of racism? And I don't know if they have, maybe they have ideas, maybe they have, or I don't know. Did you discuss those kind of things?
Yeah, we talked about it with them. I think most teenagers would like adults to be more responsible and to be more reactive when they have issues, because most of them notice that they know all of this. They are victims of insults, of sexist or racist natures, and usually when they turn to adults, they are very disappointed with their reactions. It could be their teachers, it could be their parents. So I think that, the teenagers turn to us and they are disappointed with the reaction, because I think the observation they make is that nothing happens. There are no consequences for instance, the insults that happen to them. And it's something that we observe also in later on. There is usually very little consequence when someone has insulted someone else, and it's very rare that the perpetrators are actually punished or even called in and told that what they did was wrong. So what they expect the most, I think, is a better, they expect consequences. We tell them that it's bad that people insult them, and then nothing happens. So I think that's the first expectation. And then they did really enjoy the single-sex setting. So they were not all convinced at the beginning, but in the end they all appreciated the single-sex setting, mostly because it removes one of the oppression reasons. So as we can see, it doesn't remove racism, it doesn't remove elitism, but it removes the boys, to put it simply. So they really enjoyed that. No, but really, the best week of my life never was so focused on the math. So they also really enjoyed this type of actions.
So should we remove mixity from education?
No, that's another chapter of the book. Hopefully no, but it has been proven that single-sex moments, not all education, but specific slots, is very useful to alleviate the issues that girls and women encounter.
Thank you for your talk. Yeah, so similarly, single-sex situations seems to be quite important.
Yeah.
How much, say you were to go to the extreme of saying like boys and girls should be in different schools.
Yeah.
What science would support that and what would be against it? Like,
the results we have for non-mixity shows that it's good for girls and bad for boys. That's the short answer. So that girls do fare way better when they are in single-sex settings, but they fare better in terms of experience and atmosphere. So they spend a nicer time in school. We see that research has shown no effect on their becoming professionals later on. So it shows that it's better experience at school, less sexism, less issues, but it doesn't prove that it makes more women scientists. That's the state of the art on this issue.
And why bad for boys?
Oh, because then the atmosphere degrades, because in classrooms, girls are used to calm down the boys' attitude, and so having usually when you have a mixed classroom, teachers use girls to make things run smoothly. And so with no girls, the atmosphere degrades in the classrooms.
Where usually there are a big group of girls, they tend to split and form smaller groups. Did you saw that the groups were maybe people that subissent du racisme? Oui, est-ce qu'il y a des gens qui se sont regroupés parce qu'ils faisaient partie de la même ethnicité ou parce qu'ils étaient de différentes ethnicités mais qui subissaient aussi du racisme?
No, frankly, the atmosphere of the camp was great, and all the girls say that they had a really nice time with all the other girls. So we did notice those interactions, but as Ida did, it did not lead to conflict or separation or segregation. I think the racialized girls just dealt with it the way Ida did in the example, but it did not in the end really affect the atmosphere. And actually, this goes also against the idea that when you put too many women together, they'll all turn on each other. This is also a common idea. If you have too many women, then it's bad for them also. To my knowledge, there is no research proving that, but I will look for it because it's an argument that I hear quite often. So, but no, we did not observe that in the camp.
Okay,
Very last question.
Thank you very much for the presentation. Can you comment quickly anything about the LGBTQ plus community in math?
Yeah. Very interesting question. The place of LGBTQ people. Again, very, very little data about that. We know there is some discrimination. I know firsthand. I've got a lot of examples and anecdotes about that. I've looked into it. I couldn't find any compelling research or knowledge yet about, for instance, are there more LGBTQ people in some fields than in others? To my knowledge, we don't know. How does it interact with other forms of discriminations? We don't know. I think some discrimination is common to all oppressed groups. So you can be a girl or a person of color or a person with, I didn't mention disability also, but there is also the issue of discriminating against people with disabilities. Some of the experience is common to everyone. So if you're not the poster perfect mathematician, then someone will blame you for it and you will lose opportunity for it. It could be for any of those reasons. But about the specificity of the experience, frankly, I just know that the science community is not as open on these issues as we want it to be and as we sometimes say it is. And that was actually I don't know if I showed this slide, but one of the specificity of math is actually that it believes in its neutrality. And that's one of the other specificity is that the community of mathematicians tend to believe that because they have the mathematical and logical reasoning, then they are one of the least discriminating communities. Well, no. So this is true for all kinds of discriminations, including discrimination against LGBTQA+ people. But it's really lacking. We don't know much.
I'd like to make a comment.
Sure.
So I believe that here we are already a very biased set of people because we are here. So it's kind of. But I really want to thank you because you brought a lot of questions and you make us think a lot. And really, thank you for this. It was fantastic.
Thank you.
So yeah, let's thank Clémence again.